So welcome back. Today general organic chemistry GOC organic reaction mechanisms. So very important GOC. So for first year students. So it is for first year student. So GOC general organic chemistry. So very important students are confusing that. So how to recognize the electron donor and electron acceptor. So so strong, so what are the groups? For example, strong activating group. Okay, what are the strong ring activating groups? Are NH2 group and so OH minus ion. So these two are very strong activating groups. And moderate activating groups, another one classification, moderate ring activating groups. Moderate ring activating groups are so O C double bond O are like that, because so once it is, for example, so it is like that, it is there C double bond O R, and partially these electrons are so involved in resonance towards the ring, and also it can be involved in a, so for example amides are there, so NH and C double bond O are so like that. These and all moderate ring activating groups. And weak, another one is the weak ring activating groups. Weak ring activating groups. So what are the weak ring alkyl groups? Alkyl. So for example benzene ring is there, methyl is there, and ethyl is there, and isopropyl is there, and iso like that butyl is there. So these alkyl groups are weak ring activating groups. And another important is that here the methyl is there and here ethyl, but here you can see that because of ortho position is a steric hindrance is there, steric hindrance. So this steric factor and mostly influences so that incoming nucleophile will go at para position. So now the ring activating groups, either NH2 or OH or OCOR or NH. So in these groups the incoming electrophile goes to either ortho position or para position. Ortho or para position, very important. So ortho directing group or para directing group. So how we can easily recognize? So you have to look at these groups. So another one, so another classification is that deactivating group. So what is the ring deactivating groups? Very strong deactivating groups are strong deactivating groups like NO2, very strong nitro, and tertiary alkyl N plus R3, and even trialka this CX3 like CF3 and CBr3 like that, it is there, even CCl3. So that means that, for example, the ring is containing CF3 or CBr3 or NO2 or like that trialkyl ammonium, like that N plus will be there. So that this is the very strong deactivating group. So once the very strong deactivating groups, the incoming electrophile goes to the meta position, very important, goes to the third position. Okay, so this is the ortho and this is the meta position. So the meta position goes to the electrophile. So electrophile goes to the meta position. Students, please remember that. So what is the important ring deactivating groups like nitro or trialkyl ammonium or CX3, if it is there, it goes to the meta position. And another one, moderate deactivating groups, and it is the like aldehydes is there, you know that CO and COOR and anhydrides CO it is. So now the ring is directly connecting to C double bond O or CN, you know that C multiple bonds like CN. If it is there, it is a moderate ring deactivating. So this also a meta directing group. this also meta directing group. Another important, even chlorine is there and bromine is there and iodine. So these and all weak ring deactivating groups, very important, weak ring deactivating groups. So now we know that what are the groups can be a strongly activating group, moderate ring activating group and weak ring activating group, and another one. So deactivating strong deactivating groups, moderate ring deactivating groups and weak. So chlorine Cl minus, Br minus, I minus, this and all weak ring deactivating groups. So now how to identify? So now the question is that identify the nature of each group. So now we need to identify nature of each group. So for example, this is the benzene ring, and here CH3 is there, and here NO2 is there, and here OH is there. So student, please remember that now this is the NO2. Nitro is very strong deactivating group, and another one, this is the strong activating group, and this is the weak ring activating group because it is alkyl group. So now that's why electrophile so electrophile goes to the ortho or para position. The para position already occupied. So now the para position is already occupied, so that the incoming electrophile goes to the ortho position. So this is the ortho position. So easily you can identify that incoming electrophile goes to the ortho position of hydroxy group. So that is the, so now the electrophile, so now CH3 and here NO2 and here OH, so here electrophile goes to at ortho position. So this is the identification. And example 2, so we look at the example 2. For example, so here isopropyl is there and NO2 is there. So very important. So now NO2 is the strong ring deactivating group, and whereas this one is the weak ring activating group. So this isopropyl is the ring activating group, whereas this one is ring deactivating. So now this one is ortho or para, but ortho position because of steric hindrance, because of steric factor, because of steric hindrance of this alkyl group, and the preferred electrophile goes to the, so now electrophile goes to the para position. So what is the product? The product is that, so like this, because this is the benzene ring and isopropyl, and here NO2 and here electrophile. So the why the para position is preferred? Because of ortho position is sterically hindered. So that is the very important. So this is the simple method to identify. So another example you can see that. So for example, so please arrange what are the electrophilic substitution reaction. For example, you can see that, and here NO2 is there and OH is there, and here OH is there and O methoxy is there. So among this one, this is the order of electrophilic substitution reactions. You can see this is the ring activating group, and this is also this is the strong ring activating group, moderate. So that the fourth one is a very strong reactive towards the electrophilic substitution reactions. And now this is the nitro group is very strong deactivating group, and this is the strong activating group. So next one is the bromine, because of it is a weak ring deactivating group. So second is more reactive, and because here OH is there, and so that the third one is more reactive than first one. So this is the order of reactivity. So this one, because of strong ring deactivating group, electrophile goes to the meta position, and here goes to the ortho position or meta position, para position. Electrophile goes to the ortho. But you can see, because of this is the ring activating group, already nitro group is there at ortho position, so that the electrophile goes to the para position. So here also, because already at ortho position methoxide is occupied and another electrophile goes to the at para position. So this is the simplest way to identify. So incoming electrophile goes to the, and another example we look at another. So another one, so this is the bromobenzene and isopropyl benzene and nitrobenzene and acetophenone. So last example is anisole OCH3. So now, based on this concept, we can apply this concept and we can predict the ortho or para or meta position. So now this is the bromine alkyl. So bromine is the weak ring deactivating group, so that it is undergoes ortho or para, and this is also so weak ring activating group, so this is also ortho para directing group, and this is strong ring deactivating group, electron minus m group, so that it is a meta directing group. And because of this carbonyl is there, C double bond O, also a moderate ring deactivating group, so that because of it also it undergo meta position. And now, whereas this one is a ring moderate ring activating group, so it will ortho or para position. So this is the, like that we have to identify the electrophilic substitution reactivity. So another example, we look at that. And so now this is the bromo 4-nitrobenzene and isopropyl nitrobenzene and dinitro. So in all these case, for example, so OCH3 and NO2. So in all these examples, you can look at carefully, because the now this is the one is the electron withdrawing group and strong deactivating group and weak active. So now electrophile goes to the ortho position because it is a ring deactivating group, and here also the nitro is there and isopropyl. So now this is the a weak ring activating group, so that the electrophile goes to the ortho position, because the para position already nitro group is occupied. So in this one, because it is also electron withdrawing group and this is also ring deactivating group, so preferably goes to the meta position. So meta position, and this is, so another one you can see that. So another example you can see here is that this one 4-nitromethoxy benzene, but this is the moderate ring activating group, so that it is a ortho para directing group, but at already para position is occupied nitro group, so that electrophile goes to the ortho position. So this is the very simplest method to identify electrophile which position, ortho or para or meta directing group. Thank you.